Hey, so welcome to the session about event queues scheduling. We will learn a lot about how you can use the outbox and task scheduling in combination, giving you the ultimate resilience in the messaging area and in the task execution area, as we will learn today. Yeah,
Yep.
as well for Node as for Java. The presenters today are Sebastian van Sickel, Lars Blessing, and Dietrich Mostovoy. And yeah, with that, all are, by the way, from the CAP team. So insider information as much as you like here. Let's see how much they will reveal. Okay. With that, I think, Sebastian, you can get started. Take over. It's your stage.
Thank you very much. Yes, so I'm here. I'm going to talk about these things a little bit, show some slides, and then the colleagues are going to do the real work with some demos. One in Node.js with Lars, and Dietrich will give one in Java. So I don't know who was here last year at reCAP. We had a rather similar talk where we were kind of exploring this topic and going into it, and we had an alpha scheduling API and so forth. And now what we have here is basically the evolution of it. I still want to, of course, pick everybody up where they are. So we're going to quickly go into motivation, why it matters, and then we're going to do some demos because we want to show you code. So the motivation at the end is the simple fact that distributed side effects, be it a database and a message broker or two databases or multiple, are really, really hard to get right. Because a two-phase commit would always mean that you have to somehow interact with each other and synchronize on things. And even if you would do that extra effort, there can still, on the second commit can still fail at some point due to some whatever reason. So what's the simple answer for this? We use this transactional outbox pattern, meaning we put the work that we want to do in one atomicity group into one database. And then when that commits, it's all going to be in there. And whatever we put in there, we can retry and retry and retry until we are able to propagate the information to either the message broker, the remote service, or whatever. At some point, of course, we can also give up. We can say, okay, now it's done. It became a dead letter. You can't do anything. But then you have a record of this, and you can do some manual compensation on it, right? So that's the way to get this two-phase commit problem solved by aiming for eventual consistency, right? And that is what the transactional outbox in general does, a general microservice pattern. And what we do in CAP is we take this transactional outbox pattern and generalize it. So you don't only have it for outbound communication, that's the outbox part of it, but you also have it for inbox communication, meaning you can take a message from a message broker, put it in your database, do a quick acknowledgement to the message broker, and then process it asynchronously, also with retries and everything else built in. I think was mentioned in the keynote earlier. So if Kafka sends you lots of messages, you will not be able to process them synchronously at that same speed. You can put them in the database. You can work them off one by one until you're finished. And that's what, called flatten the curve. Actually, Dietrich showed inbox last year at reCAP. You can probably still look at the recording somewhere. So there was a Java demo there. The outbox is already on by default in CAP for messaging, for audit log integration. The inbox is not yet on by default because we still want to invest in some more tooling there. So if you have a Kafka, for example, you have some tooling when it comes to dead letters. They retry, and at some point they're going to stop retrying. You can do replays and stuff like this. We don't have this kind of tooling yet. That's why we did not turn the inbox on by default. But if you want to, it's very easy to configure. You can check in the documentation. And the third aspect of this generalized outbox pattern are the scheduled tasks that we now have. We had, again, last year an experimental version in Java, in Node.js, sorry. Now we have the GA version, and we also have it in Java. And what we do here is we can run periodic tasks. We can run delayed tasks. For example, replication. We're going to see in one demo, if you have some internal caches that you want to refresh, if you have to send out email reminders, whatever you want to do, if you want to clean up some data, you can program it into your application. On server start, you say, I want to run the following task every 10 minutes, every 1 hour, following a specific cron pattern, whatever. You can do that, and then that handler that implements this will be called in one of your app instances that is running. That's what this idempotent singletons is. I'm going to show you those a little bit in a second. But first, going back to the guiding principles of all three of these things, and that is, again, that we write everything in the same transaction as your business data is written to the database, so we achieve atomicity, meaning you will never have the issue that you send an event to an external system, but then the initial transaction was rolled back, which would be then a phantom event, and you don't have any lost events because you committed locally, your server crashed, and you were never able to reach the outbound service. Second one is that you have this background runner running asynchronously after basically the heavy synchronous workload was done. Imagine you have the UI user in front of the UI. You don't want them to have to maybe wait for something to be done with some kind of remote service. But you can have like fast response times to the users, and you can be sure that you put that work away and it will be processed later on. Achieving these fast request handling and durable side effects. And the last one is, of course, that we have the resilience built in because we have retime mechanisms. And again, we have a max attempts count, right? We won't try forever. It's configurable, but you shouldn't try forever. And we have an expansional backup implemented. So each try, the delay is longer until we start it. But at some point, you just have to give up and say, okay, I need some human to look at the message. What's wrong with it? Why can I not send this message to a remote system? Maybe it has, there's a syntactical error. Maybe there's a configuration of the destination broken, authentication, whatever, these sorts of things. But yeah, you can see them in your dead letter queue. You can maybe fix the error, maybe not, but at least you can have some kind of compensation action and then retry again by reviving the message. One thing that comes up oftentimes is the question, what's the difference between our event queues and some pub/sub mechanisms, I guess from the this queues notion. And basically, so quick clarification here is that this pub/sub is more something that you have, of course, between services in your microservice architecture that are loosely coupled, where you just blast out some information and you have subscribers on the other side consuming them, but you don't have any feedback loop here. And event queues, on the other hand, is locally in your server, but of course, with the inbox and the outbox meant to reach out to external parties. So basically what it does is it builds a transactional bridge over your pub/sub, so it complements the thing. But it could also, again, only be server local if you say, I don't have messaging, I don't have remote systems, I just want to do some cleanup work periodically, then it could also, of course, never leave your server. Okay, now going back to the evolution that happened. So last year, again, we had this early API, only Node.js. What we did back then is still when we had multiple app instances running at the same time, they have to coordinate each other with the messages. What they did is they locked them on the database for processing. Of course, and then they held the lock on the database for as long as they needed to process the message, and then released it. We've since then invested in status-based locks. So basically, we do a quick select for update, set the status to, okay, it is being processed right now by somebody else, leave it alone, please, and release the lock directly again in order to, do not have these long-lived database locks. And one major feature, and Dietrich is going to show that in this demo, is the central schedule that we have. And that's especially important for multi-tenancy. I don't want to spoiler too much, but at the end is you need to basically be able to, when your app starts, know that there is work to be done for tenant ABC and not for Z, for example. And that's what this, and it's also not only that it has to be done, but when it has to be done. And that is, we put this in a central schedule. So it makes it much more efficient. And so that means we're now in a production grade state, again, for Node.js and Java, for custom apps and SaaS applications alike. And here I quickly wanted to, before we're going to hand over to the demo parts, also briefly show the new scheduling API. So the one on the left looks very similar to the version we had last time, the Node.js version, where you, on any service, can just call the schedule function. And it's a Fluent API where you can append after for a delay. You can append every for an interval. It can be a time string like this. It could be milliseconds as a number. It can be a cron pattern, either 5 or 6 digit long. And yeah, internally, we will calculate always the next execution time and call it. One quick hint that if you do it like this, like 10 minutes, these 10 minutes, basically the stopwatch starts when the last execution finished. Right? So it's not between start points, it's not 10 minutes, but between end of the previous run and the start of the next run is going to be 10 minutes. So could be a slight drift. And what we actually learned is that these scheduled events, they basically always need to be singletons, especially, and that was a big gap we actually had in the experimental API, is that when you have in a cluster, you're running several app instances and each of them are bootstrapping, and you would schedule work in all of them. Of course, you would have the task 10 times, let's say if you have 10 horizontal scale out. So what we do is by default, we make them singletons, and we default the event name. So in this case, cleanup or replicate as this single identifier, but with these as Fluent API option, you can give it a custom name as well. And so that guarantees it doesn't matter how many app instances are booted up at the same time, how often they boot up, you will always remain with one task in your database, so you don't have too many executions of the same thing, which can, of course, replication is not a big deal, but in other things it could be a big deal, right? So that's our exactly once guarantee here. On the right side, in Java, you have this schedulable that you need to create from the outbox that you use, and then you have basically the same. So you create a schedule down here. Also have an every duration. In Java, there's an extra cron method in order to pass a cron pattern, but from the it's very, very similar API that we have. And again, we're gonna see those in the demos. So now I'm gonna hand over to Lars. He's gonna show how to implement a Saga in Node.js. And yeah, over to you.
Okay. Okay, let's first start up X slides and then sorry, maybe I have louder and then X travels. So use them as you may be this session. So and thank you. Okay. So picture microservices each cases. One owns the travels, and the other owns site seed image sites. A single user booking has to touch both. And the classical answer for that would be action, a two-phase practice that would tie these two services together. And now I have to take that microphone and speak into that. Okay. This hold logs across the network, and this results in one slow service, and everybody has to wait. And today I want to show you the CAP way instead. And as Sebastian already said, this would be a Saga on top of the transactional outbox for the write side and a safe scheduled replication for the read side. Each service saves its own data through the shared events. First, we have a look at the travel service and the model from X Travels. Here we can see the new state. We created the so-called status. There is O for open, C for confirmed, and F for failed. And of course, a booking starts with open. Now we have a look at the service chairs from X Travels. Here we can see this one line. This wraps the whole remote service. Now every event we send through this handle is stored in an outbox table in the same local transaction as a travel and its bookings. Either both are saved or neither is, and that is how we stay consistent without a two-phase commit. Now to the save handler down below here. After the save, we emit booking created. Two things to notice here: we use emit and not send. So we fire and forget, and we pass travel ID and position. So the reply will find our booking again. Now to the events down below here: hashtag succeeded and failed. Those are the built-in follow-up events. The event queue fires one or the other automatically. On success, we flip the booking status to C, and on failure to F. Notice there is no rollback, because when the booking is never confirmed, there is nothing to take back here, and the user can just see the update of the status and can retry. Now to the data service. From X-Flights, we subscribe to the booking created event. Two things I wanted to see here. First, the conditional update. We only add 2 occupied seats if there are enough free seats available. The database itself checks in one step. No AppSet locking, no race. If nothing was updated, then we call rec-reject. That reject then travels back through the event queue and becomes booking created hashtag failed on the caller side. And second of all, after updating seats, X-Flights emits this flight updated event that carries no seat count. That is on purpose, because events can arrive out of order. If you put the number in the message, an older message could override the newer one, and the copy would be wrong. So the event only says something has changed for this flight. This booking service then rereads the current seats from X-Flights and then updates its local copy. So we put that all into action through data federation. The booking service needs flight data for value help lookups. Therefore, we annotated flights and supplements with TDS persistence table, which turns them into local replica tables. To keep them in sync, we have 2 things here. As I already said, we use or subscribed to this flight updated event. This is the live update layer. Whenever the inventory service emits flight updated, we can see here the booking service reads the current seats and updates the local copy here. And as the second part, we use our schedule API. Here we have also this .name task. This is used as a singleton. This ensures deduplication across restarts and instances. So every 10 minutes, the event queue picks up 1 replication task for each entity. And in our case, it would only be 2, the flights and the supplements. We use this in the value help lookups. So here in the UI, I can just show you it quickly. Just select the travel, click on edit, and then click on create. And here we can see the flights. Here we can see that those are not coming from the inventory service, but from Xtablet's own local copy, filled by that schedule replication task. And that is why the value lookups are instant and no round trips are needed. Now we have a look at the booking flow itself. First of all, let's see if free seats are available. We can send that by that GET request and have a look here. And we can see that there are still 7 free seats available. And therefore, we can create a new travel by sending this post here. We can send it, and we can now watch the logs. They logged everything because there we can see the 5 numbered steps. Number 1, the booking service emits booking created. Number 2, the inventory service confirms it and reduces the free seats. Number 3, the inventory service emits flights updated. Number 4, the booking succeeded event arrives and updates the booking status to confirmed. And at last, number 5, the booking service rereads the current free seats and updates its local copy. Now we can have a look at the object page. Here I can refresh it. And here we can see the booking status was actually confirmed. Now the question, what happens if the flight is fully booked? Therefore, I can create 6 more travels. 1, 2, 3, 4, 5, 6. And now send. And yes, we have no more free seats available. And now I send this request down below here. And I also prepared that object page here. refresh it, and we can see the booking status is still open. Going back to the terminals, we can see the booking status was rejected because it's fully booked. In the other one, we are seeing the retry mechanism in place. I configured max attempts with 6, so there should be 6 retries. After the last one, we see the booking failed event. Now I refresh that page here, and we can see the booking status actually changed to false. So the booking stays as a record of what we tried. Nothing was brought back because there is nothing we can take back. Their failure is in fact about a business, not a technical undo. So let's recap what we saw. The whole thing is event track consistent. We just fire and forget, and the client only sees the update of the status and then can decide whether or not he should retry. Everything happens to an reaction to an event. Recurring jobs run on a schedule across many instances, and they still just fire once. So the event queue does have a lifting, and your code stays focused on the business. And that was basically it. And I will hand over to Dietrich now.
Hi, I hope you can hear me. Yeah. Good. So I finally tried to convince you to use our Outbox implementation, because trying to do it by your own is really, really complicated. So let's start with a problem statement. Imagine if you put any kind of events into the Outbox by submitting, we have to trigger somehow the asynchronous mechanism which starts the asynchronous collector, which is reading all the events in the Outbox and execute them. And this exactly can lead to a problem. Imagine if you lose your application instance, it's crashed, or on a scale down, then this trigger is not executed, and the event is not lost, but it's not performed by the asynchronous collector because it's sleeping. And if no events are coming in at the startup of the new instance, then this event would not be executed. And if you imagine you have a job which is running 1 time a week or a month, this could be really annoying. And for that reason, we had to consider somehow to create a recovery mechanism so that we can periodically look into the persistence, look into the Outbox, and execute these lying events. And if you have a multi-tenancy environment, then you have to do this for every tenant, because each tenant has its own persistence, and because of the transactional option, we have to use the Outbox for each tenant in their own persistence. And if you have and it's quite obvious that you can take all the tenants, loop over them, look into the Outboxes, and if they are not empty, start the asynchronous collector, and everything would be fine. And it works really, and we call this approach all tenant task. And as long as you have only 10 or 20 tenants, it works really good. But what if you have a lot of tenants, and we have stakeholders, they have not only 10 or 15 or 100, they have even thousands of tenants. And for that, you cannot loop over all tenants, because in this case, you need tenant switches, which means in terms of HANA, you have to switch the schema. It's really expensive, and you would also damage your connection pools, which is also not the target. And in the real world, the most tenants are idling, so this approach would not be suitable for these situations. So we had customers that complained that they couldn't even not start the application if they have a lot of tenants, because this alternate task is busy and they have to switch it off, and then they lose this reliability feature for the events. So for that reason, we had to consider how we can smartly solve this issue, and we call this hot tenant task. So we try to determine the tenants that are busy that were busy as a hot tenant, and we created a hidden outbox in a shared memory, persistent memory. Not all customers have provider persistence, but we have the MTXS persistency that we can use for that. And hidden means in that terms that you cannot find it in the service catalog as a service, so that the customers cannot use it to waste with other stuff. And it's exclusively for our hot tenant management. And this is a normal, usual outbox. And we put each time when you submit a message, we put a small outbox event into this hidden hot tenant outbox with the tenant information and schedule it in the future. So we can imagine this as a backup task. I show you maybe this in a small example. I created a small application with 2 tenants, and I used our dashboard. I hope you can see that. And I simulate a few outbox events, and what you can see, if I start maybe an immediate event, not in the future, then you see in the task overview that a task is executed for this tenant, but you see also a system task for this tenant. It's still there and it's used as a backup task. Some time later, it looks into the tenant persistence and checks if something is there. Then it triggers the asynchronous collector. If not, it's removed from the scheduler. And for the demo, I configured the periods to the shorter time so that you can see. And if I start now events in the future, you will see I have a lot of load in my schedule, and this backup task periodically checks, and if something is there, as I said, they don't vanish. The checks once again, and if I would stop the application now, it would happen like a crash. Start it again. With that, we need just only one hidden outbox where you can look into it and recover all the backup tasks. And this backup task in turn recovers all the events for our hot tenants. And as you can see, we recovered completely the old state. And the benefit of this approach is that to some point of time when the system is idling, we will also get into the idle state without processing heavy stuff just for insurance that everything is there. And I think that's all. And you will see after 1 minute, I think, the application will stay in an idle state. So I think that's all from my side.
Take this one. Yeah, thanks. Okay. Okay. So yeah. So thanks for the demos. So what you saw, especially in the second one, is this new hidden outbox we call, or I would have said central schedule, but it's just the 2 runtime teams. I'm from Node.js. We have some different vernacular for some things, but yeah. So we put that automatically in there in MTXS, so you don't have to deal with that. So yeah, to wrap up at the end, and I want to leave some time for Q&A, is that what we try to do is at the end of the day follow the same mantra that CAP always has: best practices served out of the box. So we didn't reinvent the wheel. We checked what is transactional outbox pattern, what's event sourcing, what are Saga patterns, and just try to build them in for you. Almost all batteries included. As I said, for inbox, we're not there yet. That's why it's not on by default. But scheduling API is now GA. Outbox has been there for years, actually, on the outgoing side. When it comes, maybe one addition to the callbacks that Lars showed, this hashtag succeeded and hashtag failed callback events, those are still alpha. Those are still only available for Node.js. So they are, also one of the topics we have to tackle. So again, not all batteries included yet, but that's what we try to do. So we try to create a very easy way to make your workload asynchronous, make it durable within the same transaction as the business data, so you have these durable side events and side effects. And one more thing to mention here is that we revisited or reworked basically the entire event queues documentation. That was also a major gap previously, that they were somehow scattered snippets in CapHire for Node.js and Java, but we now have a new reworked, freshly rewritten central guide for event queues with minor jump-offs to the stacks. And yeah, for that, then I'm finished, and we have some time for Q&A, I hope.
Thanks, Sebastian, for handing over. As already mentioned, we have time for Q&A. Are there questions in the room? Okay.
First of all, thank you for bringing the outbox pattern, much needed resilience patterns for Node.js. But I just want to quickly ask you if this pattern, the Saga pattern that you defined here, is how does it handle race conditions? Has it been thought out, or if you tested, if there are multiple threads doing the same stuff, how is it handled? Do you get into a deadlock, or you handle it asynchronously as well? Because I see an orchestration here, I mean, a choreography between the events here, but will there be a central orchestrator which says, hey, this service needs to go do something? And I just want to understand if that is being taken care as well out of the box.
Yeah, so great question. So what we purposefully don't do is assume any orchestration between these events. They are all seen as individual ones. The stacks differ a bit in their implementation because of their threading nature. So Node.js will, in Java, you can have multiple threads to process the messages. In Node.js, of course, you're on single threaded, but we select a certain chunk size of messages and just run them in parallel. But they are all considered to be individual events that do not, by definition, can race against each other. If you have something like this where you really need a sequence, then you need to bundle them. Right? So you have to ensure that they are, for example, you could do it, and again, it's Node.js only right now, but trigger the second emit in the succeeded callback of the first or something like that in order to put the order in yourself. But for us, they are completely independent.
Other questions? Yeah, I remember something.
Yeah. Because there was another session with some outbox. The question is, like you mentioned Kafka, but that is mainly used SAP internal. When now customers or partners want to go for splitting the microservices, what is the standard to put in between? So event mesh, and is there auto configuration? What's the best approach?
Yeah, a tough question. It was SAP Event Mesh, right? I think the new one would be an Event Mesh and Integration Suite, which we now support with Node.js CDS 10, Java hopefully very soon. But yeah, there's been the message broker landscape on BTP is a little bit fluctuating. We're trying to keep up. But so I think the new question would be to Event Mesh. PM's probably better. I would think they probably say Event Mesh and Integration Suite is the way to go. Or Event Hub if you want to consume S4 events.
Okay, let's check Oh, it also works. Perfect. So you have no shortage on microphones, as it seems. Okay, another question here in the room. Okay. The distances get longer. And for everybody here in the room, while I'm on my way, the next session will be a yoga session for 10 minutes. So if you're interested, stay in the room.
Great, thank you. You mentioned Event Hub for S4 events. Never seen that one. Just seen the event mesh natively integrated in S4 systems.
Yeah, it's SAP Business Application Event Hub, I think is the product name.
Okay.
The plugin, it's we a CapJS plugin for that on the Node.js side called Event Broker, because previously that was their name, then they changed it, but our name still is Event Broker.
Okay.
And that's the one where you can configure your S4 system with communication agreements, blah blah, to send specific events that you can then consume in your CAP application.
So meaning over the same channel, topic publishment channel as before, but it was only available via the event mesh name.
Same. Also, you use in CAP, you use the same topic annotation for it. It's just then a configuration on the S4 side, or basically the adapter configuration on both sides, how the message reaches you, but yes.
Great news.
Okay, we would have time for one, or at least one additional question. Is there one in the chat? Okay.
So the question is how to balance job scheduler, in parentheses external / or flexible, versus new scheduler, internal but hard-coded. Yeah, great question, tough question for me to answer. I would say that I'm not sure about how hard-coded these things are. Yes, they are basically for you, of course, as an application developer. You will have a hard time having your customer configure anything there. But you could have a periodic test, you hard code yourself and look up some customer configuration if you were supposed to run something or not. At the end of the day, it's kind of a little bit of a political question that I would like to not answer. I'm also not an expert on job scheduler. Maybe it can do a lot more things that we can't do, but at the end, you can just advertise that you can create scheduled events in CAP natively now with cron patterns or intervals. And if it suits you, use it.
These are wise final words for this Q&A session. Thank you, Sebastian. Thank you, Dietrich. Thank you, Lars, for being here and giving us all these insights. And as I mentioned before, everybody is jumping out of the room. Marion is already here. She is the lady who is giving a 10-minute yoga session to get a bit more relaxed and get a bit of movement. So if you want to participate, and I highly recommend to participate, please simply stay in the room. Yeah? Okay, thanks.